Hello students, welcome to our YouTube channel. So this is Ajit Kumar, chemistry teacher who is handling class 10 chemistry, and in the upcoming videos I will be teaching you chemistry of class 10 CBSE board. So especially in this video I will just give you a basic introduction of what are the chapters present in our class 10 chemistry, and then I will be starting off with small introduction and with a small topics of the first chapter. So let us get into this video. First, let us discuss what are the chapters present in our class 10 in chemistry. So the first chapter, it deals about chemical reactions and equations. So this is just a basic fundamental of class 10 for chemistry. So we will be discussing what is a chemical reaction, what are the types of chemical reactions present, and how can we mention it in the form of chemical equation. So these all comprises of chapter 1. In the second chapter, acids, bases and salts. Already you would have known what is an acid, what is a base and how the salts are formed. So specifically in this second chapter, we will be discussing chemical properties of acids as well as bases and also of salts. We will be discussing in detail about specifically about 5 salts. We will be discussing how it is being prepared and what are the uses of that salts, especially we will be discussing in this second chapter. Third chapter, metals and non-metals. We would have already studied the physical properties of metals and non-metals in the previous grades. But here, in addition to physical properties, we will also be discussing about chemical properties of metals as well as non-metals, like how metals reacts with air, how metal reacts with water, how metal reacts with acid. These kind of chemical properties we will be discussing in third chapter. And also in addition to that, we will be discussing how a metal reacts with a non-metal. What is the mechanism which is being followed when a metal and non-metal reacts? These things we will be discussing. And the most importantly, we will be discussing how the metals are being extracted from the earth based on their reactivity, like high reactive metals, medium reactivity metals, low reactivity metals. So this, based on the reactivity, we have different techniques to be applied for the extraction. This we will be studying in the third chapter. And in the fourth chapter, we will be entirely discussing about carbon and its compounds, like how carbon, what kind of bonds will be formed by carbon, what are the compounds formed by the carbon, like say for example, you would have studied alkane, alkene, alkyne, like this hydrocarbons are there. We will be discussing in detail in fourth chapter, carbon and its compounds. And at the last, periodic classification of elements. So this chapter entirely deals about periodic table. I hope you would all know what is periodic table. You would have seen the periodic table, right? So in this chapter, we will be discussing how the periodic table has been evolved from generation to generation. Who are the scientists who gave attempt in the formation of the periodic table? What are the properties they used for the preparation of periodic table? So these things we will be discussing in detail one by one in the upcoming videos. So in this video, we will be specially discussing about chemical reactions and equations. I will just give you a small introduction to this chapter. Let us get inside. Chapter 1. So in the very beginning of this chapter, we are discussing about what are chemical reactions. Okay. You know, chemical reactions are nothing but chemical changes. There are two kinds of changes that we can observe in this surroundings. One is physical change and the other one is chemical change. So chemical changes can also be called as chemical reactions. So a chemical reaction is a process where a reactant gets converted into a product. Okay. Say for example, when magnesium reacts with oxygen, we can say it forms as magnesium oxide. So the substances which is going to react, we call it as reactants. Reactants will always be written on the left hand side of the chemical equation. And this magnesium oxide, we call it as products. Products are nothing but the substances which we get after the reaction. That is what we call it as products. And keep in mind that reactants will always be present in the left side of the chemical equation and products will always be present in the right side of the chemical equation. And this arrow mark represents that the chemical reaction is happening. It has been converted from reactant to the product. So if you see these lines, a word equation shows change of reactants to products through an arrow placed between them. So this is the arrow which is being represented. The next thing, the reactants are written on the left hand side. Please keep in mind that reactants are always written in the left hand side, and products will be written on the right hand side of the chemical equation. The arrow points towards the products and shows the direction of the reaction. This shows the direction of the reaction. From reactants, it reacts together and it forms a product. So this is the actual meaning of writing a chemical equation, and this is the chemical reaction. So the next thing what we are going to discuss is, how do we identify a chemical reaction? How can we assume or how can we predict that chemical reaction has happened or not? So to help for that, there are 4 criteria mentioned here. With that help, you can just tell whether the chemical reaction has happened or not. So the first criteria is change in state. Okay, with the help of change in states you know, right, there are 3 kinds of state. One is solid, the other thing is liquid, and the other state is gas. So if you could observe some kind of change in state, you can say that a chemical reaction has happened. See the second criteria, change in color. So during the reaction, if you could observe any change in color, then you can assume that the chemical reaction has happened. The next thing, evolution of gas. Evolution nothing but liberation. Like if the reaction is happening, from that you could observe a gas being evolved out. So that we can call it as a chemical reaction. The next thing is change in temperature. During the reaction, if you could observe any change in temperature, then also we can call that as a chemical reaction. But please keep in mind that it is not necessary that all the 4 criteria must be happening. Either if one observation is also you are able to observe, then you could also call it as a chemical reaction. By now you would have seen these images, and you could, I think you could have guessed what are those images representing. Yes, this image, first image, represents change in state. Yes, and the second image represents change in temperature, and the third image, it represents change in color, and the last 4th image, it represents evolution of gas. So these are the images just to show how the changes are happening based on state, color, gas, and then temperature. Fine. We'll move to the next slide. Now, writing a chemical reaction. How to write a chemical reaction? Before getting into that, why should we write chemical reactions in the form of chemical equations? Many of you would have, to many of you this question may be arise, why we have to write it in the form of equations? The thing is, say for example, this experiment shows burning of magnesium ribbon. I think you all would have experienced this experiment in your school, in a chemistry laboratory. You know, magnesium ribbon, when it burns, it forms magnesium oxide. So if you want to write it in the form of word equation, you will be writing like this, right? Magnesium, when it is burning in presence of oxygen, gives magnesium oxide. Like this you would be writing. So, will it be possible to write all the chemical reactions in like this in the form of word equation? No, it will not be easy for us to mention all the chemical reactions in the form of word equation. So to help in that case, chemical symbols as well as chemical formulas help us to write it in the form of chemical equation. So if you see, magnesium symbol we know it as Mg, and oxygen gas we know it as O2. So these both reactants combine together to form a new product, and that product is called as magnesium oxide, MgO. Few students will have doubt how this magnesium oxide is being formed. To help in that case, you would have studied, some students would have known in this term crisscross method, few students will know in this term swap method, right? So the first step, write the symbol of both the atoms here, okay, magnesium Mg, oxygen it is O. You know the valency of magnesium is 2 and valency of oxygen is also 2. So if we swap or if you apply crisscross method over here, it will be forming as Mg2O2. So is it possible for us to simplify further? Yes. So divide by 2. Now you will get it as MgO. Few students will have doubt why we have to divide by 2. Since we have common numbers in both the cases, we can divide it, and we must always present the chemical formulas in simplified form. So, magnesium oxide is being formed. So, this is called as chemical equation, and this is called as chemical word equation. So, which will be easy for us? Yes, chemical equations will be easy for us to represent the chemical reactions. In addition to this, there are few informations which we get from the chemical equations if we write it in this form. Say for example, magnesium. The states in which the atoms exist are solid, liquid, and then gas. You know all this, right? So, to represent if that substance is in solid state, what we could use is, we could use S as the symbol. If it is in liquid state, you could mention it as small l, and if it is in gaseous state, mention it as G. For example, if it is in aqueous state, you could write it as AQ. Okay. And one more thing, if there is any evolution of gas, if gas is being evolved from that reaction, we can use upward arrow mark. Okay. And if there is any formation of precipitate, I know this term will be new to you, precipitate. In the upcoming topics, I will be discussing what is precipitate and how it is being formed. Okay, don't worry. As for now, just learn what are the symbol we use for these terms. For precipitate, we use downward arrow mark. Is that clear, students? So, just learn the symbols for representing each state. Now, if we take this same equation as an example, magnesium, it will be existing in solid state. So, put S over here. Okay. Oxygen, it will be existing in gaseous state. And then magnesium oxide, solid state. Like this you have to represent. So, by writing it in the form of chemical equations, we could also get some more information on what are the states in the reaction is being proceeded, and which temperature it is happening, is there any formation of gas, precipitate. These kind of informations we get to know from the writing in the form of chemical equation. Fine. The next thing what we are going to discuss is balancing a chemical equation. This topic few students will be almost familiar. Okay. Before getting into the balancing chemical equation, why we have to balance a chemical equation? This question arises. Why? What is the need to balance a chemical equation? The thing is, see here, sometimes a written equation does not have equal number of reactants and products. In reactant side and product side, it will not be equally balanced. So, according to this law of conservation of mass, in your previous grade 9th standard, you would have studied laws of chemical combinations, right? The first law is law of constant proportion, and the second law is law of conservation of mass. According to law of conservation of mass, it states that atoms can neither be created nor be destroyed in a chemical equation. So, atoms on the destroy create, but it transfers from one form to the another form. That is what happening in a chemical equation. So, we have to equally balance the atoms in the reactant side and the product side. This is the reason why we balance the chemical equation. So, if we want to balance, we can't directly go and balance the chemical equation. There are certain steps and procedures that we must follow to balance the chemical equation. So, just see the slide, see the first step, count the number of atoms of each element present in the product side as well as the reactant side. I will discuss you with one example, just learn the steps alone first, later we will discuss with few examples. Second step, determine the atoms that are unbalanced. You have to check which are all the atoms unbalanced on the both the sides, reactant side and product side. Step 3, balance one atom at a time. We should not balance all the atoms at the same time. It is wrong. So, to make it easy, balance each atom at a time. Okay? And then step 4, once if you have balanced all the atoms, at last check the equation again whether it is equally balanced or not. Many of the students will make mistake here. You will just balance it, you will just go to the next question. Don't do that. Even if you have balanced it, take few seconds of time, check again whether it is completely balanced or not. Okay, students. Now we will discuss with one example. I have given you one question here. Iron plus H2O gives Fe3O4 plus H2 iron oxide plus hydrogen gas. When you come to see this question, you can solve this question there. I will be solving here, you can just solve it there. The first step is, you have to segregate it as reactants and products. Okay. What is the next step? You have to list the number of atoms present here. So if you see this equation, first atom is Fe, iron, and the next atom is hydrogen, and the next atom is oxygen. Okay. Is there any other atom other than these three? No. So if it is not there, you can move on to the next step. Iron, in the reactant side, how many atoms are present? Yes, it is 1. In the product side, how many atoms are present? Yes, it is 3. Okay. Now move on to hydrogen. In the reactant side, it is 2, and the product side, it is also 2. Okay, students. Now oxygen, it is, the reactant side, it is 1, and the product side, it is 4. So this is the first step. You have to segregate it as reactants, products, list the atoms present here. The next thing is, write the number of atoms present in reactant side and the product side. Second step. What is the second step? We have to check which atom is unbalanced. Okay. So if you check in this tabular column, hydrogen, it is balanced, equally balanced on both the side, reactant side and the product side. Oxygen, here it is 1, but here it is 4. So this atom we have to balance, it is unbalanced. Iron, if you check, here it is 1, here it is 3. So it is also unbalanced, iron and oxygen. These two atoms we are going to balance. And an easy way or a trick to balance a chemical equation is, if there is oxygen atom in the given equation or in the given question, balance it at the last. Don't go straight away and balance the oxygen atom, because it will be giving some troubles to you. So to avoid time management, to easily balance the chemical equations, you can just take oxygen atom at the last. Okay. Step 3, balance one atom at a time. First we will take iron atom. You write the equation again, Fe plus H2O gives Fe3O4 plus hydrogen gas H2. This is the equation, right? So here it is 3, whereas here it is only 1. So what number we can put? And the thing is, we cannot reduce the number of atoms present here. Okay. If it is in higher number, higher value, we cannot reduce that, because it has formed based on their valency. So the only way for us to balance a chemical equation is, we can just increase this number to equally balance it. Okay. So iron, here it is 3, here it is 1. So shall I put 3 over here? No, it is a wrong way to put the number here. So the correct way to write the number or to balance a chemical equation is, you should write before the compound, or you can say it as a coefficient. You in maths you would have studied what is a coefficient, right? So you should put 3 over here. Now if you see 3 iron and here also 3 Fe. So it is equally balanced. Hydrogen, it is already balanced. Now check oxygen. Here it is 1, whereas here it is 4. So what can we do? Yes, I can put 4 over here. Okay. If I put 4 over here, this 4 is common for hydrogen as well as oxygen. Please keep in mind that. Now check oxygen, 4 oxygen, 4 oxygen. But hydrogen, it has been changed now. 4 2s are 8 hydrogen is present in the reactant side, whereas here it is only 2 hydrogen. So what can we do? Put 4 over here. Okay. Now if you check step 4, what is the step 4? Recheck the balance the chemical equations. 3 Fe, okay, and then in the product side it is also 3 Fe. The next thing is hydrogen, 4 2s are 8 hydrogen, here it also it is 8 hydrogen. Oxygen, 4 oxygen here in the reactant side, here also it is 4. So like this you have to do stepwise, only then you will be feeling easy to balance the chemical equations. Don't go directly and solve it in the equation. Follow the steps given, practice more and more equations, and then you will be feeling easy to balance a chemical equation. Okay students, fine. I will show an image how chemical equations are balanced. So this equation represents hydrogen gas reacting with chlorine gas, it produces hydrochloric acid or HCl. Okay, just see this image. By seeing the image itself, I hope you will be able to understand why balancing chemical equations are required, right? So in this unbalanced equation, you just take 2 hydrogen atoms are present and 2 chlorine atoms are present, and it is being formed as HCl, hydrochloric acid. See the slanting position, reactant side it is heavier and the product side it is very light. Okay, so to balance it or to equally place it, what we are going to do is we are going to put one more hydrogen atom and one more chlorine atom. So if you see this image, it represents a equally balanced chemical equation. So just see H2 plus Cl2 gives 2HCl. So this 2 is common for hydrogen as well as chlorine. Okay, so now it is equally balanced. So you have to follow the steps properly, only then it will be easy for you to balance the chemical equations. Fine. And I have put some practice questions over here. When you see this video, you could directly start to solve these equations. I will be solving here, you solve it there, and at the last we will cross check the answers. Okay. Sodium hydroxide plus sulfuric acid gives sodium sulfate plus water. There are chances of asking questions even in the form of word equation. Few cases they may ask directly by giving the chemical equation. Some cases they will be giving you in the form of word equations. So in that case, you must be able to write the chemical formulas. If you are doing mistake in writing the chemical formulas itself, even if you balance the equations, it will be wrong. Okay, so learn to form the chemical formulas using that swap method or so-called crisscross method. First learn that and then come to this part. Okay, first thing, sodium hydroxide. I will also teach you in this equation how the chemical formulas are being formed. Sodium hydroxide. I will just do it here. Sodium symbol Na, hydroxide symbol is OH. Okay, and sodium valency, you know, it is 1 and hydroxide valency is also 1. So if you put swap method, it will be forming as NaOH plus sulfuric acid. What is the formula of sulfuric acid? Right, H2SO4. Don't get confused with hydrochloric acid and sulfuric acid. Hydrochloric acid, it is HCl. Sulfuric acid, H2SO4. And nitric acid, the formula is HNO3. Okay, so these are the major acids we know. So in this equation they have mentioned sulfuric acid. So it produces sodium sulfate. Okay, sodium symbol we know Na, sulfate symbol it is SO4, sodium valency 1 and sulfate valency it is 2. So if we swap, it will be forming as Na2SO4. Okay, this is how it is being formed. So just write the equation here. Na2SO4 plus water, you know it is H2O. Like this you have to write. Okay. The first step of balancing a chemical equation is reactant and product. You can just write it in the short form also, no worries in that. Then write the list of atoms present. Sodium, oxygen, hydrogen, and then what are the atoms present? Sulfur. Is there any other atom other than this? Sodium, oxygen, hydrogen and sulfur? Just check it in the equation. No, right? So sodium, oxygen, hydrogen, sulfur. Okay, just write the list of atoms and write the number of atoms present in each case. Sodium here it is 1, whereas there it is 2. Okay, and then check oxygen. Here it is 1. 1 plus 4 it is 5. Okay, they are asking overall the reactant side, not just one reactant and the other reactant. In overall the reactants, you just count the number of atoms. Oxygen 1 plus 4 it is 5. Here also 4 plus 1 5. So it is equally balanced already. Okay. Next, hydrogen. Here it is 1. Here it is 2. So 1 plus 2 it is 3. The product side it is 2. And then sulfur, if you check, here it is 1 and also here it is 1. So 1, 1. This is the first step. We have segregated it as reactants and products. Okay. Now the step 2, we have to check which atom is balanced and which atom is unbalanced. Okay. See, oxygen it is already balanced. Sulfur also it is already balanced. The unbalanced atoms are sodium and hydrogen. These two atoms we are going to balance it now. So what can we do? Sodium reactant side it is 1, product side it is 2. So which number if we put it will be equally balanced? Yes, it is 2. So put 2 over here. Okay. Now check 2 sodium, 2 sodium. So just put one tick mark. We have balanced the sodium atom. If I put the number before the compound, this 2 is common for sodium, oxygen as well as hydrogen. Now the terms have been changed, the number of atoms has been changed. So don't look here again, okay, just count the number of atoms again here. Now we are going to balance hydrogen, okay, 2 hydrogen plus 2, 4 hydrogen is being present in the reactant side. Check here, only 2 hydrogen is present. So what can we do? Here it is 4, there it is 2. So it is lacking by number 2. So put 2 over here. 2 2s are 4, 2 plus 2, 4. So now it is equally balanced. Hydrogen is also balanced. Now check oxygen, 2 oxygen plus 4, 6 oxygen is there. Whereas here 4 plus 2, 6. So it is automatically balanced. So no worries in that. Now come to sulfur. Here it is 1, here also it is 1. So it is already balanced. So this is the step to balance the chemical equations. I think you would have written the correct answer, right? Yes. The next question, magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen gas. What is the first step? Reactant, product. Okay. First write the number of atoms or the list of atoms present. Magnesium, hydrogen, chlorine. Check whether any other atoms are present other than this. No, right? Okay. Magnesium, reactant side 1, product side also 1. Then next hydrogen, it is 1 over here, here it is 2. Okay students. Next chlorine, here it is 1, product side it is 2. So if you check this tabular column, magnesium is already balanced, hydrogen and chlorine it is unbalanced. So what can we do? First we will start off with hydrogen. Reactant side 1, product side 2. So what number can we put? Yes, 2. So where can I put 2 here? Put 2 in this place, 2 HCl. Okay, now check 2 hydrogen, 2 hydrogen. It is balanced. So just put a tick mark. Magnesium, it is already balanced. Okay, now check chlorine. 2 chlorine is there. Reactant side, just now we have put 2 over here. So this 2 is common for hydrogen as well as chlorine. So it is automatically balanced. What is the step 4? Check again whether it is equally balanced or not. 1 magnesium, 2 hydrogen, 2 hydrogen, and then 2 chlorine, 2 chlorine. Okay students, so by the end of this video, you would have learnt what is a chemical reaction, how the chemical equations are being represented, and what are the informations do we infer from the chemical equations, and then we would have discussed about balancing chemical equations in both the cases, if they are given it in the word equation or if they have given it in the form of directly in the chemical equation. So that's it with this video students. The next video we will be discussing about the types of chemical reaction. There are about 5 types of chemical reactions. We will be discussing each reaction in detail in the next video. Okay students, thank you all.